Good morning, everyone. Today, I would like to introduce a recent study we have published on the Superhydrophobic pencil-on-paper platform for detection of multiple signals with decoupled sensing mechanism. This is a work based on our previous publication, where we showed the pencil-on-paper platform can capture the moisture from the ambient environment and also from the skin perspiration to characterize the insensible sweat and be able to characterize the skin barrier function. And we are pretty happy it can work as designed and can also capture the moisture from different locations, like from the diaper in a remote condition without contamination. And that's why we would like to pursue it a bit further to see how we can leverage this further for the detection of the other signals, including temperature, electrophysiological signals, and gas molecule that are a good indicator for health conditions. That's why we embark on this interesting study. And of course, as we learn this is super sensitive to moisture, we have to design the sensor in a way that it can block the effect from the moisture. And that's why we first introduced a superhydrophobic coating in terms of a superhydrophobic silicon dioxide nanoparticle. It can drive out the moisture effect by rolling out all of the moisture or water molecules from the sensor surface, and then it can go after the other sensing signals. And of course, when we have the sensor responsive to multiple input signals, the question is whether we can decouple them. Otherwise, one input signal might interfere with the others. So that's why here our key idea and innovation is to decouple all of these signals from each other. And this gets to be a bit easier because we have multiple ways from the previous research in our group to do this magic job. So in terms of physiological signals, in terms of the biopotential we capture from the heart for ECG, from the muscle for EMG, from the heart, brain for EEG, and they are all based on the voltage signal. So we know it's different from the resistance signal we monitor for the temperature and gas. So once we have this voltage signal, we know it's the electrophysiological signal. And we can use that one to directly characterize the EMG, ECG, or EEG. When we get the resistance signal, and it comes from the temperature and gas, of course a bit challenging to decouple these two, but luckily we have a previous publication and design strategies that can allow us to decouple these two from each other. In brief, is to leverage two separate units. One is with the encapsulation layer, that is a polymer going to block the moisture and gas molecule from going through the layer. And from that, we can block the effect of the gas molecule, but thermal conduction can still happen. So temperature can still be detected as long as this layer in terms of encapsulation is thin enough. It does not slow down the transfer of the heat. So we can still detect the temperature in a rapid manner. On the other side, we have another unit without this encapsulation layer, but with a self-heating. So it can heat up the temperature to about 50 degrees C also, and is located in just the small localized region. So it does not change the overall thermal output, but rather just at this location. And this provides us the capability to be independent from the variation in the ambient temperature, because this location is already 50 degrees C. So from this sensor, we can eliminate the effect from temperature, but just be able to detect the gas molecule. And putting these two units side by side, we'll be able to decouple the temperature from the gas molecule, as we have shown in a recent paper. And so by putting all of these different considerations together, we were able to detect the electrophysiological signals from the voltage signal and the temperature and gas with decoupled sensing based on the two units we just talked about. And further, of course, this platform is not adhesive to the skin surface, and we further leverage the sugar. It's type of sugar that's very sticky, so it can be applied to the skin surface without irritation, and it can be there for a couple of days without any problem. So we are pretty happy about this platform, and thank you for listening.